and welcome back to chemistry class. Today I am going to start our next chapter, that is state of matter. Before this we have finished second book, and today we will start this chapter, state of matter. So let us begin from initiative points of this chapter. So what is the initiative point? State of matter means what is the matter. So you might be knowing what is a matter, but I would like to revise once time. Here, what is the matter? Anything that occupies space and have mass is known as matter. What is anything that occupies space and have mass is known as matter. Here in matter, if you see here, matter exists in 5 states, but in your book it is given only 3. Matter exists in 5 states, but in your book it is given only 3. So let us see what are the state of matter and what are the factors responsible for state of matter, and how does the state of matters are being decided, and how do they decide the chemical property and physical property. Is there any relation with the state of matter to reactivity of the matters toward chemicals and towards chemical reactions? So let us see here, students. Here we will see state of matter. State of matter, anything that occupies space and have mass is known as matter. Yes, state of matter. There are 5 types of matter, means there are following states. First is solid, liquid, gas, plasma, and boson state. But in your book it is given only 3. Here it is given only 3. In your book it is given only 3. So let us discuss here the state of matter. State of matter we are discussing here. What are the state of matter here? As solid, liquid, gas, plasma, and Bose-Einstein. Bose-Einstein. So let us see what is the role of state of matter and what are the factors that affect the state of matter. Okay. So let us see here. Means in solid, you might be knowing, if we talk about this here, solid have this one like this arrangement. Liquid has this arrangement, and gases have this arrangement. And plasma and Bose-Einstein states can't be represented like this because they have intermediate of these things, so it could not be represented. But we come to know there are 5 states of matter here, and in 5 states of matter, especially we will discuss about solid, liquid, and gases only. And Bose-Einstein, Bose-Einstein and plasma states are also there. So there are 5 states of matter. Okay, and if we see here, state of matter. So state of matter is being decided by the intermolecular forces here. Let us see here intermolecular forces. So if we see here in the intermolecular means the force act between 2 molecules or atom to particles is known as intermolecular forces. Means the force act between 2 molecules is known as intermolecular forces. And if we see here, this just if you see here, this is intermolecular distance. It is internuclear. Sorry, we can say internuclear distance. This is internuclear distance. It is internuclear distance here, and the attraction between these is intermolecular attraction or intermolecular attraction. We can say intermolecular attraction. So let us see here intermolecular attraction and internuclear attraction. How does it affect the reactivity of these things? So intermolecular forces here, let us see here. These are state of matter is physical quality. Physical quality means state of matter is physical quality. So let us see how does physical quality affect the reactivity of, and is any variation in this? Yes, let us see here. So state of matter is physical quantity. If we see here, physical quality we see here. So physical quality means in this, if we see here, just see, they may in different state, but their chemical formula is same. Means they may affect the reactivity. What points should be noted? Means they have, means state of matter may vary, but they have similar chemical formula. If we take here what ice, just see, ice, liquid, and vapor. ice, liquid and vapor. If I am asking you to write the chemical formula of these three, so what you will write? You will write H2O. But what you will say, sir, that this is ice, that means this is solid, and that is liquid, and this is gaseous form. So what is difference? What is difference in that? Yes, we observe that they have a similar chemical formula, but if we talk about, they are affecting the rate of reaction. They are affecting the rate of reaction. Means symbol points if you see here, means state of matter, means it may have the similar chemical formula, but their rate of reaction is varying. Means like this, if we talk here. So student, let us see here. How does the chemical properties are depending on the state of matter. So it is normally observed that the rate of reaction of matters may be vary if state of matter is changing, but chemical properties not being affected. And what is the reason and what are the factors behind that matter exists in solid, liquid and gases? So let us see this topic here. So only the factor is that intermolecular forces. The intermolecular forces are responsible for existing of matter in different states. Like that, we talk about the solid. Intermolecular species are much more, while in liquid the intermolecular forces are little lesser, and in gas it is less. So let us see what is the order of intermolecular forces here. In solid, intermolecular forces, if we talk in solid, intermolecular forces are more. In liquid it is less, little less than that, and in gases it is least. So what idea you got? You got idea that intermolecular forces is highest in solid and lowest in gases. Highest in solid and lowest in gases. Okay, or weakest, we can say weakest. So what are intermolecular forces? Let us see what are intermolecular forces. Just all see, if we are taking the molecules, here are constituent, and what is the attraction between them? What is the attraction between? That is called intermolecular forces. Intermolecular forces. Molecular forces. And attraction, if we talk in terms of attraction, that will, and if we talk here internuclear distance, this is called internuclear distance. Internuclear distance. And other points, if we talk here internuclear distance, other point if we talk here, so one point we are getting here. What is that? Point is that the interaction is directly related to kinetic energy. Means you know that all the states of matter are free to move, but in solid state it just vibrate. In liquid it will flow, and in gas it is freely move. So if we see here internuclear distance and intermolecular attraction forces and kinetic energy, we see particles kinetic energy. So kinetic energy is directly proportional to internuclear forces. Internuclear forces means internuclear distance is more, kinetic energy will be more. Kinetic energy, just what we see here, kinetic energy will be more if internuclear forces are more. And other points we try to get from here. So arrangement of the particles means only the 5 internuclear forces are responsible for arranging the particles in different state, and internuclear forces are responsible to arrange the particles in matter. Okay, so let us see here, students, in matter. So we talk here about the internuclear forces. So here we will talk about internuclear forces. So what are the internuclear forces? The forces acting between two particles. In that, maybe atom molecules is known as internuclear forces. Here internuclear forces. So internuclear force, if we talk here, we will talk here van der Waals forces. And it means internuclear forces is a type of van der Waals forces, and van der Waals forces is of 3 types: dispersion forces, dipole forces, and dipole induced dipole forces. What? There are three type of van der Waals forces: dispersion forces, dipole forces, and dipole induced dipole forces. Before we discuss this one by one, let us discuss some more point about the attraction between the particles. So here, just sort of say here, hydrogen bonding we have already discussed here. Hydrogen bonding. So it is not intermolecular attraction, intermolecular force. It is not being included in this. Other part we see here means electrostatic force is not taken as a intermolecular. Other point here, electrostatic and covalent forces. You might be knowing what are the covalent forces. One by one we will discuss here. Covalent force. So what is the factor here? Let us see here. Hydrogen bonding is not being considered as internuclear forces, intermolecular forces, and here we talk about electrostatic forces and covalent forces. So let us see when do they exist. They exist when hydrogen bonding, you know that it is a hydrogen bonding is limited to some elements only. Means hydrogen bonding is not present in all type of matters, in all states of matter. Only in few it is present. So it is not considered as intermolecular force. If we talk in electrostatic, so electrostatic force is also limited only oppositely charged. So electrostatic forces are related to oppositely charged here. It is limited to oppositely charged. Okay, means like this, if we write here Na plus and Cl, so there it is active. Oppositely charged here. Okay, and covalent forces are limited up to only covalent compound. So these things are not included as intermolecular forces. Only van der Waals force is included as internuclear force. And van der Waals force, what is the van der Waals force? Let us see here. Van der Waals force is just one type of attraction that attracts the constituent particle. We will not say that attracts the constituent particle. Means van der Waals attraction or van der Waals force is always present in a matter, and these also present in the matter. All the matters are classified in different category due to different type of attraction, but these are not being included here. So students, let us see here what is van der Waals force. So let us see children here, one more time we can revise it here. What is intermolecular forces? So intermolecular forces is type of attraction or repulsion between interacting particles. Intermolecular forces is type of attraction or repulsion between reacting particles. Okay, so let us see here. Attractive internuclear force are known as van der Waals force. Attractive internuclear force are act as van der Waals. Means van der Waals force act in all the state of matter, but it may be different type that we have seen that van der Waals forces are of different type that we will discuss later one by one. But these are not being included as van der Waals forces. So what is the reason these two are not included as van der Waals forces? So what is the reason why do they are not included as van der Waals forces? So let us see students, van der Waals forces, this is covalent force. Covalent force is limited to only covalent compounds. It is limited to covalent compound. It means it holds the covalently bonded atoms together. It holds covalently bonded atoms together. It doesn't exist in all the matters. So it is not included here. If we talk here electrostatic, so it always act in oppositely charged ions like NaCl in that NaCl. So it is also limited to some compound. So these are not being taken as internuclear forces. These are not taken as internuclear forces. So once more we can see internuclear force act between all type of matters, whatever are. Okay, and it is just attractive or repulsive force between reacting participants or interacting participants. Interacting particles, we can say interacting interacting species, we can say. Okay, and attractive internuclear forces are known as van der Waal. For attractive internuclear forces are known as van der. Just to see here, internuclear forces may be attraction or repulsion. Attraction or repulsion maybe, but here attractive nuclear means van der Waal force is only attractive force. It is only attractive force. So let us see here, students. Attractive internuclear forces are that attractive internuclear forces known as van der Waal forces. Attractive internuclear forces are known as van der Waal forces. Okay, students, and this was discovered by the scientist Johnson van der Waal, and it helps to clear the deviation of ideal gas from normal gas. Ideal gas and from normal gas. So that we will discuss later. Okay. So students, let us see here van der Waal forces. Van der Waal forces. Van der Waal forces are of the three types. Dispersion force or London force. Second is dipole force, and third is dipole induced dipole force. What are they? They are a dispersion force or London force, and next is dipole forces, and third is dipole induced dipole force. So let us see here one by one. So first we are going to discuss dispersion forces or London forces. Yeah. So I would like to explain this with the help of a story. So you might be excited to know a story. Yes, it is very interesting here. So let us see. There were two friends. And they were doing all the things together. Means when they study, they do all the things, but they never study. They do all the work, but they never study. What happens? Once a person came and scolded one friend, and he is entirely motivated. One friend entirely motivated, and he started studying. So second one also started studying. Means when one is doing something, by seeing, by inspired with that, other is doing. Okay, so story belong to this here. These are the two friends A and B. Okay, means these are the two atoms here. They are symmetrically. Means they are symmetrical. Why? Means charge is distribution. Charge is distributed over all the atom is similar. So we say symmetrical distribution of electron charge cloud. Means both are symmetrical. Both A and B are symmetrical. Means charge is distributed uniformly in this. Okay, like this A, that is B. What happens when momently or instantaneously the charge of A get disbalanced? It means for time being for time being you might be knowing that electrons are revolving, and for timing the charge get disbalance, not imbalance. Disbalance means positively charged move this side and negatively charged move this side. Positive charge move this side, negative charge move this side. Means here, just to see, a dipole is produced in the molecule, and this dipole has produced dipole in B. This dipole has produced dipole in B. It means here, just you see, in this charge, positive charge is this side and negative charge electron I have shown like this in that also. So here we can see atom A with instantaneous dipole more electron density on right side. Electron density is right side more. Okay. And atom B induced dipole. What is dispersion force or London force? One more time I would like to explain here. So let us see, students, here means these two are symmetrical atoms. These two A and B are symmetrical atoms, means electron is distributed uniformly in the atom. You might be knowing, except nucleus. And suddenly it happens the electron clouds of one atoms move either of the side. Either of side. In this we have observed that electron is moving right side. Electron is moving right side. So it produces dipole in the molecule. Due to dipole of this, it attract this electron, attract nucleus of that, and it attract towards this. So polarization is produced in atom P also. Polarization is produced in atom V, and what we observe that A has produced the dipole moment in V, and we say induced dipole moment. What is? Who has induced? A has induced. Because of A, B has polarized dipole is produced in B due to A. So what I told, when one friend has started studying, seeing him other also, and second friend also started studying. So who has inspired? Who has induced the dipole moment? Means friend A has induced the dipole moment in friend V. So we say this type of temporary dipole moment is known as dispersion force or London force. One more time I would like to clear here. There were two friends, that is A and B, and if we talk here the atoms, these are the atoms. In this what is observed that it is symmetrically distributed, electrons are symmetrically distributed, and in this for timing the charge means positive charge move either of the side, means in this it move this side, and negatively charged move right side. So this has produced dipole moment, and due to this dipole moment is produced in that, and this is known as dispersion force or London force. And just you see one more time, just students please listen here. So what is there? Just you see here atom, and here when atom A with instantaneous dipole moment, more electron, means in this what is, this is symmetrical but it is unsymmetrical, because in this the charge has moved that side and this charge has moved this side. So when electron and possibly charge move the opposite sides, and this electrons means density is more right side of this, it attracts the nucleus, means positive charge of other atoms, and it induces the dipole in this, and this is known as induced dipole. Okay students? So students, what we also this one more time I would like to revise here, just in 1 minute here. These two are symmetrical atoms, in this electron is symmetrically distributed. What happens in this, for timing in atoms, electron moves one side and positive charge move one side. Okay, here in this electron moves right side, left side. And here dipole means electron density is more, electron means positive charge is more. So in other sense we talk here, this electron will attract nucleus of other atom because this one is closer to that, and that will induce the dipole in atom B. So we said induced dipole or dispersion force or London force here. Okay, means one is being affected by other. One is being affected by other, means dipole movement is produced in second atom due to shifting or slightly moving of charge of one atom. Slightly moving of charge of one atom. So we say induced dipole. Okay, let us see what is other relation here. This is only attractive interaction energy. This is attractive interaction energy. This is attractive interaction energy. This is attractive interaction energy, and it is inversely proportional to sixth power of the interacting species. Means it is distance, r is distance between two interacting species. R is the distance, and it is applicable up to 500 pm picometer. That is, means up to this distance it is applicable. These things are observed, and beyond this dipole or dispersion force or London force can't be observed. It means up to 500 pm is picometer. These things are observed. Beyond that it can't be observed. And here its value means induced dipole depends on polarizability of this. How nicely it is polarizing, that much induced dipole will be produced in this. If this one is polarized nicely, means if electrons and positive charge are separated properly, so more dipole moments will be produced in second one. If it could not do like that, so less dipole moments will be produced. So one more time here, just sort of see here, means here dipole interaction or dispersion London force here, dispersion force is directly proportional to polarizability. Polarizability means if a polarization is more, so dipole induced dipole will be more, or London force will be more. If polarizability is less, induced polarizability will be less. So students, just sort of see, it is very simple concept. If you remember one line, this line, if one is being affected by others, is this concept here. One story I share with you related to this, means one student is studying more and other is being affected by that, by seeing him. So it is called induced dipole, or what we can say dispersion force or London force. Okay students, and this is applicable up to 500 pm, not more than that. Pm is picometer, and if distance between the interacting particle, means it is directly inversely proportional to the sixth power of interacting particles, means and r is internuclear distance between, or we can say a distance between interacting particles. Okay, thank you so much students.